Hi, I'm Mike Bush.
I'm Paul New.
And I'm Colleen Sterling. Welcome to Ask the A&Ps from AOPA.
On Ask the A&Ps, we take your toughest maintenance questions and we try to solve them. We don't always solve them, but we try to solve them. So if you have a question, especially if it's a tough question, reach out to us at podcasts@aopa.org.
And if you like the show, make sure to follow or subscribe so you never miss an episode, even if we sound like frogs.
We'll have to talk about that, Paul. And if you'd like to get on our email list for our monthly newsletter and some interesting maintenance stories, I'm actually writing up a couple of them right now to send out. The easiest way to do that, if you're in North America, is to pull out your mobile phone and text the word SAVVY, SAVVY, to 33777, and a little text bot will ask you for your email address and put you on the list. Again, text the word SAVVY, SAVVY, to 33777 to put yourself on our list.
Sorry about the frog thing.
Just would you explain yourself?
Well,
Ribbit.
I have some sort of virus. It's not COVID like it was last year. So
the frog virus, deadly.
The frog virus. I think that's the thing. So I don't feel nearly as bad as I sound, but I'm at I think I'm like day 12 of a 10-day something. Yeah, it's just hanging on. I'll survive.
You took a week off of work to try to recover from this?
I did miss, probably missed about 3 or 4 days. Yeah.
That's pretty bad.
And on one of those days, you very graciously gave it to Helen, right?
Yeah. Well, I have this theory, we had a family gathering, and I think Helen's symptoms presented a couple of days later than mine, but a couple of the grandkids got sick and one of the children got sick. So I don't know that I am the perpetrator. I may be. I'm gonna claim that anyway. Try not to be. So
not that I know a lot about kids, but I've heard kids are germ magnets.
They're just walking. They're just walking petri dishes. Yeah, they're horrible in that way.
Yeah.
But I'm gonna try real hard to keep the mute button close by for when those the coughing that cannot be stopped. I'll hit that and try to save the editors a lot of work.
Yeah.
So if we see your mouth moving but no sound, we'll know what's going on.
Yeah, just you can tell me, Paul, you need to unmute. There's been a particular problem with the ADs that have come out because I've gotten, like with the 210, I've gotten a huge number of phone calls.
Oh, I'll bet.
I had a couple of days where I felt like coming to work, but I couldn't talk. And so it's been very frustrating.
Yeah, I'll bet your phone's been ringing off the hook. You're probably the place in the country for the Cessna, the carry-through spar AD.
Yeah, probably. And the thing is, we already have a packed schedule, like every other shop in the country.
Right.
And so I'm thinking about the AD on the Continental engines as well.
Right.
How in the world we're gonna fit these in? We've turned away. Well, Blake and I were talking about it this morning. We've probably turned away 15 210 spar inspections because we're packed with existing 210 customers that will have to have it. And, we want to accommodate, but man, I don't know how it's going to happen.
This is a huge problem because we're in the middle of a gigantic mechanic shortage in general aviation. I wrote an article back in 2020 titled "The Looming Mechanic Shortage."
Yeah, it's not looming anymore.
It is not looming anymore.
It's right there.
And an awful lot of shops are booked up a year in advance.
Yeah.
They tell their annual inspection customers to schedule their next annual as they're picking up their airplane from the last one because the schedule is so packed. And then something like this Continental AD or this Cardinal and 210 AD comes along, and there's just no capacity in the system to deal with it. And aircraft owners are unfortunately going to wind up on the beach for a while because there's just nobody to do these things that are being mandated.
Well, In the 210 one, you got to be careful. There's a lot of people that can do engine work. Most shops, can pull cylinders, but like the 210 and the Cardinal, once you take it to the shop for the inspection, if anything is found, that is probably going to be the shop that's going to replace the spar. And so you need to really consider, are they
There's-
capable?
Are you saying no ferry permits will be permitted?
They have stated that. I think there will be some allowance depending on what's found.
When
But
you
if
say
you-
they've stated that, are you saying the AD?
In the
said
AD,
no?
yeah. It's grounded until the repair is made, and there's no further flight. I think some airplanes will be able to get ferry permits, but the majority, if they
If it's
find a
that
problem,
bad, yeah.
you're not going to get it. And I'm thinking mostly of the Cardinals. The 79 and newer 210s all came from the factory with corrosion inhibiting.
yeah.
They're all primed, and they're probably in good shape. I think what we're going to find on those is damage from upholstery screws, which is it's
Oh.
what failed the two that I know about that were replaced. One was replaced at my shop.
So it creates a hole and it goes through the corrosion proofing and then it becomes corroded in the hole.
No, it didn't.
Or-
It's just a hole.
It's just the
It's
hole,
just
and
a
that's
hole.
enough to trigger.
That's all you got to have. If something
Interesting.
is deeper than, depending on where it is, 10 to 30 thousandths of an inch, and a screw can make a hole easily. We had one that had 4 holes that were 1/8 inch in diameter and an 1/8 inch deep.
Oh, that was an earnest mechanic with a
Oh
big
yeah,
screwdriver.
but I'm telling you, it held that headliner
Yeah.
plastic just beautifully. It's
wasn't
just
going anywhere.
It wasn't going anywhere.
This thing wore a dent. You call it a hole, but it's like an
Well,
indentation.
these were actually a drilled hole.
Oh, wow.
But
Oh,
other
my.
ones, yeah, other
Oh,
ones
he
they'll
drilled.
use it.
Oh God,
They yeah, they weren't.
I've seen
threaded, though.
that with wing spars, where some
Yeah,
well-meaning
yes.
mechanic will
Yeah. Well, then others
use a
they'll
drill
put
stop.
the PK screws or sheet metal screws
Mm-hmm.
in through to hold it, and those little sharp ends just sit there and they just vibrate, and
Yep.
nobody pays any attention. And 2 years or 3 years later or whatever, there's these nice little hogged out holes
Yeah.
that and they've gotten too deep and they're stuck. It's not really corrosion. So, but the Cardinals, I think, are going to be. There's a lot of Cardinals that are corroded, and the last scare, the initial 210 spar AD, I think, got a lot of people's attention and got the Cardinal people looking. I know CFO did a great job of encouraging people to look,
Get an inspection. Yeah.
get an inspection done. Now it's an AD, so I think there's going to be some Cardinal ones found. Fortunately, they're a lot easier to change than a 210. But
Oh, the spar. If
the
you have
spar
to
is
replace
easier.
the
Yeah,
spar.
if you have to replace it, but there aren't any spars to replace it with.
And you don't want Joe Mechanic working off the back of his pickup truck to be changing your spar
No.
carry-through structure. That's
Yeah. It's a job. It's
Wow.
a job for a structural repair facility to do.
I can't imagine. I mean,
yeah.
I look at that thing when I take the headliner down and it's massive and all the skin is, over it. It's all enclosed. You'd have to
Yeah.
peel the skin back on the top and there's big rivets and there's big bolts driven through to hold the wings
Yeah.
on, and the wings have to come off, right?
Yeah, the wings come off first. The nice thing is you don't have to jig anything because the carry through is bolted to the frame. And once you bolt it, the new one to the frame, it's lined up. There's no
Interesting.
alignment to do. So you don't need to build any kind of jig or special fixtures. But anyway, so that's special with that one. But the engine AD, I
Now
think
we're
that-
switching gears now. This is the
well,
TCM.
yeah, this is the TCM
counterweights.
thing, and as Mike was saying, I don't know how we got a call from Cirrus, as I'm sure a lot of shops did, and the question was, "This is happening. This
how
is
many
when-
can you do?
How many can you do? When can you start?"
Uh-huh.
And I'm sure they called a lot of shops, and they were looking for shops that could do the Cirrus-owned airplanes as well, because Cirrus, as a lot of people know, grounded their fleet, not the airplanes that they've sold, but the ones that Cirrus still owned and had control of, and which I thought was a pretty bold move. It set quite a statement, seems to me, how important they thought it was. It was big.
It always goes back to I would much rather have a tried and true engine or airplane part or whatever. I don't want to be an early
Yeah.
adopter
Oh,
for
this is a
something new.
classic
Yeah.
infant mortality failure because,
Yeah.
you know, unfortunately, neither Continental nor really the FAA has been as forthcoming as I would like to have seen in terms of telling us exactly what was found to trigger this AD. And, you know, so that leaves us kind of speculating about it because nobody's really talking. And I can kind of understand why Continental isn't talking because their legal department probably doesn't want to provide any information for plaintiff lawyers to use.
Yeah.
But I've always thought that if the FAA is going to mandate something, there ought to be a requirement of transparency for them to explain exactly what persuaded them that this is an unsafe condition and that this is the appropriate applicability.
Yeah.
I mean, my sense about this Continental AD from circumstantial evidence, and I can't prove it because nobody's talking, is that we know that there were 3 counterweight releases due to this problem, 2 on the ground and 1 in the air. And we're pretty sure that they all happened in cirruses that were just coming out of the factory. So that they probably all happened at extremely low engine time, you know, like 10 hours or less.
Yeah. Or initial startup.
And Continental came out with a service bulletin that said, you know, if you've got over 200 hours time in service, don't worry about this. Basically, what they were saying is if it was going to come apart, it was going to come apart a lot quicker than 200 hours. And then the FAA said, well, Continental has not provided us enough evidence to convince us that there's no risk for engines over 200 hours. So we're going to include all of these engines, every single crankshaft assembly that was assembled in Mobile from, I think, what was it, June 2021 forward. But I would love to know more about those 3 cases and exactly when they happened, because my sense is they probably happened at super low time, and that if they wanted to, and they were, and they, you know, the government tends to be super risk averse. I mean, Continental's going to be pretty risk averse because they don't want to get sued, but the government's even more risk averse. And but my sense is that they probably could have confined this AD to a much smaller group of engines, ones that had, you know, no more than say 50 hours time in service. But nobody was willing to take that risk, and nobody's really talking about what they found and when they found it.
And so the fact that they flooded the market or the support market with all these engines that are going to need inspections is going to have 2 implications. One is that there's going to be a lot of downtime because people won't be able to get into a shop. And the other is there's a lot of aircraft that are going to have unnecessary maintenance done to them by just pulling the cylinders to do this inspection, which potentially could cascade to further issues if they're not retorqued correctly and put back on correctly.
Yeah.
So
but
bad
so
for everybody.
It would, from that standpoint, Colleen, from the collateral damage standpoint, and that's another problem that I have with the AD system, that the FAA is required to go through fairly extensive analysis before they make a determination that an unsafe condition exists that warrants an AD. They are not required to do any analysis of what risk the remedy creates. And there have been a number of ADs. I'm not saying this one is one of those that where the cure is worse than the disease.
Yeah.
But it does seem to me that the procedure for ADs ought to be changed so that the issue of
They
how
consider
much
that.
risk is
Right.
entailed in doing this thing that you have to take. Like the wing spar AD is a pretty good example. How much risk is involved in a wing spar carry through structure being replaced by a shop who's never done one before?
Yeah.
Is there
the
risk?
the risk is, I think the risk of a problem with the installation of the spar carry through is fairly minimal. I mean, it's bolted in place. You got a lot of rivets.
Rivet stuff.
Even if they do a sloppy job on the rivets, they're going to hold together pretty good. I don't worry about that.
Yeah.
I worry about the flight controls because they take the wings off,
Oh,
Yeah.
right.
and so
Re-rig
you've
everything.
interrupted electrical, which is no big deal. Fuel delivery
Fuel, yeah.
can be a big deal, and flight controls, flaps. Not too worried about flaps, but ailerons are a big thing.
And the rigging may never be the same again.
The rigging, well, it may not have been right to start with, but
Yeah.
yeah, those are. I worry more about that, all the peripheral stuff, because most of the time things get bolted on okay, but man, all the other little things. And you talked about, in the spar thing, there was a lot of known evidence that, and even the FAA pointed out that here was this spar failure in Australia. That's what got it all started quite a few years ago. And then they had a lot of data after inspecting a lot of spars. And when they came out with this new AD, they even referenced some of that and said, oh, here's why we're doing it, which to me, whether you agree with it or not, at least they kind of showed the track that they were on. But I'm with Mike on the engine deal.
Yeah.
And it's not that we shouldn't be doing the AD. I'm not disagreeing with that at all. But when people are asked to do something that's not only expensive but potentially dangerous, you want everyone to have this feeling that they
It's worth
buy
it.
into the
Yeah.
urgency,
Right.
that this is worth the risk.
Okay, our first question is from Michael, whose turbo normalizing system isn't being very normal. Go ahead, Michael.
Thank you. I love the show and love the chemistry. I'm also very glad I don't have a Cessna 210 anymore, or my not part of the 2000 affected by the AD. But I do have a turbo normalized 1979 Bonanza. It's a Western Skyways system as opposed to the more popular Tornado Alley. Love the system, except I have a nagging problem where if I go to full throttle on takeoff, it'll overboost. And so I have to go to partial throttle, 29.6 inches of manifold pressure, and I get a little lower than desired fuel flow, 28 to 30 gallons an hour, as opposed to 34, 33 gallons an hour. The controller's been overhauled. The wastegate went out to Main Turbo, who also did the controller overhaul. They inspected the actuator. They said it looked good, put it back on, readjusted the system, same problem. And so the question is, now what?
Is this something that changed suddenly, or this came on over a period of time, or it's always been this way?
Always been this way ever since I bought the airplane in 2020.
Yeah.
Okay. Well, I have a couple of comments. It's a very, very bad idea for you to try to obsessively limit your manifold pressure to 29.6 with the throttle.
Yeah.
Just let it do what it wants to do. Continental basically says that boosting up to 3 inches over red line is a non-event. What is a big event is not having enough fuel flow. We can kind of speculate as to why you're having this variation in manifold pressure from one flight to another. But the fuel flow is determined by the upper deck pressure. Okay, you've got a fuel pump that has an aneroid on it that is referenced to upper deck pressure, and it modulates the fuel flow according to upper deck pressure. So if you're getting less than the 34 gallons, it's because the upper deck pressure isn't as high as it should be. There's not much that can go wrong with that fuel pump. It can be misadjusted, but it's not going to vary from one flight to another. But I would encourage you not to try to limit your manifold pressure to 29.6 the way you seem to have been doing. You seem to think that's really important. It's not. What's important is the fuel flow. Now, look, if your manifold pressure went to 38 inches, yeah, I would say, okay, yeah, probably ought to throttle back and land and figure out what's wrong. But if it goes to 30 or 31 or 32 inches, it's just don't worry about it. Just let it happen. But
is that actually a red line on this airplane? Because on the Tornado Alley and the Cirrus, the red line is at 32. And when the early takeoff or first flight of the day, it's common that manifold pressure runs to 32. And then after you've flown for 30 seconds to a minute and everything settles in, oil temperature settles, it comes down to right around 30 and everything's where you want it. I'm just not familiar with the Western Skyways system.
It does.
Oh, go ahead.
Red line at 29.6. They do talk about overboost on the first flight of the day, but my manifold pressure as the system warms up doesn't come down, it goes up.
Yeah.
That's different.
Yeah, that's what he said. Yeah.
But how high does it go up? You're not seeing major excursions above red line, right? You're just seeing a couple inches or so.
Correct.
So just let it happen. Let it happen. By throttling back, you're reducing fuel flow pretty dramatically, and that's got to be bad for the engine. Much worse for the engine than a couple inches of overboost, which is really, consider that red line like a dotted red line. But the other thing that's a little weird about the system, because you sent us a diagram of the fact that they are using a slope controller and then kind of crippling its function by normally the slope controller, that top port that's getting the upper deck air reference, that's normally supposed to get manifold pressure, and then the bottom port, which they sort of have jumpered to the top chamber, that's supposed to be referenced to upper deck pressure. And what's inside that controller is a sealed aneroid, which gives an absolute pressure reference. But the aneroid, instead of being fixed to the housing like it would be in an absolute pressure controller, sits on a diaphragm that moves based on the differential pressure between the top chamber and the bottom chamber. And the idea is that at reduced throttle settings, where there's a significant difference between upper deck pressure and manifold pressure, the diaphragm moves and it reduces the upper deck pressure, so the turbocharger isn't working so hard. So it's kind of like a VAPC, a variable absolute pressure controller, except instead of a mechanical linkage to the throttle, it kind of has a pneumatic linkage to the throttle. That's the idea. So they've taken the slope controller and they've hobbled it by connecting the top and bottom chambers together, so that the diaphragm basically is immobilized. The slope controller thinks you're at full throttle all the time, even if you're not. So I am not sure why they did that. If they wanted an absolute pressure controller, why they didn't just put a standard
Just use
absolute
one.
pressure controller in.
Yeah.
And I'm not sure whether using a slope controller in this non-standard fashion has any kind of weird effects that could account for some of the things that you're doing. But they're clearly taking a slope controller and trying to coerce it into being an absolute pressure controller for reasons that I have no idea.
Yeah, I did.
It would be super interesting to replumb that the way God intended it to be plumbed and see what happens.
Stand back.
Science project.
Like to. I did ask.
Minor alteration, right, Paul?
I'm sure that's, yeah, just a log entry. It's all you need.
I did ask Western Skyways about the slope controller and why they chose it, and the answer I got was before our time. So
Wow.
The answer was probably they had a lot of them in inventory
Just sitting
at one
around.
time.
Yeah.
So what are we going
can
to
use
do with
these
all
up.
these?
Yeah, we can get rid of these. Like all the straight slotted screws that the Brits still use on their airplanes. It's like we have a bazillion of them left over from World War II. Let's just keep using these.
But I mean, I think the main comment is don't be so obsessed with manifold pressure to redline. Be more concerned about fuel flow, because a few inches of additional manifold pressure isn't gonna hurt anything.
So how far does it creep up on a normal flight? You take off and it's 29 point whatever, and as you fly, how much more manifold pressure does it give?
1 to 2 inches.
Oh,
Hey,
Okay.
it
I
sounds like
thought Mike was going to be honest and say, I don't know because I never let it get above.
yeah.
Tried it once.
Yeah.
what I'm hearing is that Mike's got not a turbo normalized engine, but a turboed engine that's actually going more than normalized. And what pilot ever complains about having too much power?
Oh,
It's
I
just,
know one.
hey, it's like taking off from Death Valley. You
Yeah.
just get a little extra on a cold day.
It sounds like you've got the perfect situation. It gets stronger as you climb,
As you climb, yeah.
and we're telling you to just let it go over boost on takeoff. So wow, that's great.
I had a normally aspirated 210 owner not complain. He was tongue in cheek, but he said he was taking off from sea level in Florida on a really cold day. And he commented to the whole group that, man, I had to pull the throttle back on takeoff today because I had too much manifold pressure. And I was in shock. I thought, first off, your manifold pressure has no red line on it on a normally aspirated engine. Why would any pilot ever pull the throttle back? So let her rip. That was wild.
That's God-given power.
That's
Take
right.
it.
That's Mother Nature.
Yeah, that's funny.
Well, thank you. I will let the ponies do their thing.
Good.
There you go.
All
Rock
right.
on.
Well, we didn't find a smoking gun for you, Michael, but at least we freed you from these entrapments of keeping your power under control.
Maybe you should sneak up on that slope controller and give it a whack with a handle of a screwdriver or something. See if that helps.
Just snip that one, connection.
I do
between the
not
up-
understand why they did it that way, but it's kind of interesting to think about what that controller does in that weird configuration. But that wasn't the way it was intended to be used.
Well, great question, and
Yeah.
lots of good data to describe it too, which really helped us, Michael. So thank you for being so thorough.
Well, again, love the show.
Thank you. Take care.
All right. Our next question is from Philip, who did something good. He's just not sure what it is, but he apparently did something good. Go ahead, Philip.
Oh, yeah. Well, thanks for having me on the show. It's great to be here. My question is this. So we are working with a customer, has an experimental aircraft, and it has a Continental IO 520 and a 3-blade Hartzell. Pretty high performance setup. And he wasn't very happy with the takeoff and climb performance. And so after some conferring with prop shops, we adjusted the low pitch stop on the prop itself. Essentially backed the governor off until it was no longer governing the prop, and then adjusted the stop to where the prop itself would hold the proper static RPM.
Yeah.
And then once that was adjusted, we put the governor back to redline. And so they're both holding the prop at redline.
Yeah.
And it
good.
seems to have made a difference. He gets better takeoff performance, climbs better. And in my mind, the governor always increases blade pitch to maintain a certain RPM.
Right.
And at full power, full manifold pressure, and redline, I would have thought that the blade angle would always be the same. However, that seems to have changed a little bit. So there's something I'm missing here. What changed? I guess is my question.
So, all right. I'm not sure I'm quite exactly sure what the question is, but I'll tell you something that we do. You can't do this easily on Macaulay, so you must be dealing with a Hartzell propeller.
Correct.
On the, well, we do the Vidito conversion on the Cessna 210, which puts a turbo-normalized IO 550. And one of the processes of the STC is to do exactly what you did. You do static runs, and you take the prop governor out of the system by adjusting it, way high, and you adjust the low pitch stop to give you roughly the 2700 that you're looking for. It doesn't have to be exact. And the whole purpose is that when you throttle up for takeoff, the engine will spool up to speed faster. As soon as you start moving forward, I call it unloading the prop. So if you don't do this, I see it on a lot of Columbias where they'll take off and may not get full RPM until they're at 40 or 50 knots. And that's just the low pitch stops are set at too high of a pitch. So you don't get the full RPM until you're down the runway a bit. So doing what you did is a perfectly fine thing to do. It yields a much better takeoff performance because you get the power earlier in the takeoff roll, and the prop governor does its exact job. Before we did the first one of these, I called our prop shop over in Memphis, and I said, so what is actually going on in this hub that I'm going to do? It's a screw with a jam nut. He said, well, the worst thing you can do is if you screw it all the way out and the jam nut and the screw fall on the ground and you go fly, then the hub, the internal hub of the prop just hits the dome, and that becomes its low pitch stop.
Okay.
So there's absolutely, you're not doing any damage internal to the prop or anything. So you don't worry about that. So all that seemed to work, right? And what is it that you're saying changed that you fixed it?
Yeah, I guess essentially it takes off quicker and climbs better. So I had thought that it seems like there's maybe more pitch in the prop on takeoff.
Well, it's actually initially the blades are at a lower pitch.
It would be less pitch.
Less pitch. So the RPM comes up fast because the engine can turn the propeller easier.
Okay.
When it gets to 27, so you're basically a fixed pitch propeller. So imagine a 172, you go to full throttle and you might get 2300 RPM statically. But as you roll down the runway, that RPM increases and increases because the airplane's now moving forward and it's easier for the prop to turn. It's the very same thing in this situation until you're going fast enough forward that the low pitch of the propeller might allow it to go past 2700. And that's when the prop governor kicks in and begins to increase the pitch to maintain that 2700 to keep it from exceeding that.
Okay. So essentially we just made so the power comes in sooner.
Right.
On takeoff.
Yep.
Okay. That makes sense.
Yeah.
That makes much more sense.
Now you said that you adjusted the low pitch stop to obtain rated static RPM. What is that static RPM? Is it something less than 2700?
2650. Does that sound right? Or right around 2700. Yeah.
Okay.
I know we set it just a little bit low, just so it would get the full RPM once the takeoff roll was started.
Yeah. Yeah, I wouldn't want to set it above 2700. We normally shoot for something around 2680, 2690. But
Okay.
anywhere in that range is good to let it power up pretty quick.
I always wondered why my RPM wasn't at redline when I started my roll. I accepted it because I knew it was normal operation, but I wasn't quite sure why. By the time I'm at the end of the runway or climbing out, it seems to go up. And I guess I always thought it was just cold oil pressure, even though,
You have a Macaulay prop, right?
yes, I do. Yes.
So if you ever send it out for a reseal, it it has the low pitch stop. There's usually a range, and you can always ask them to set it to the lower value of the low pitch stop, and that'll help it accelerate, help the engine accelerate.
So as long as the governor's working properly, you're saying it won't hurt it.
No.
The governor will be the limiting factor, not the pitch on the prop.
Exactly. That's what
Got
you
it.
want. You want the
Yeah.
propeller to be the limiting factor on a static run, but as soon as the wheels start turning, let the prop governor be the limiting factor.
Okay.
Yeah.
That's a good question.
And
Yeah.
the stop in a Macaulay is internal to the hub, right? So you
Right.
can't,
So I
it's
can't
not
do it
field
myself, yeah.
adjustable.
Right. You don't have access to it.
Got it.
But it's basically
Right
just
on.
a safety device, right?
Yeah, I guess to keep
If there
the
wasn't a low pitch stop and the governor was working correctly and you had adequate oil pressure, you really wouldn't need a low pitch stop. The governor would
right.
prevent the prop from turning too fast. But
Yep.
it's a safety device to make sure that the engine doesn't go into overspeed.
Right. But I can tell you, if someone misinstalls your prop governor and your prop governor doesn't do its job and you find out somewhere after you're airborne, your engine will run at something above
Yeah.
2,700.
Oh, for
Oh,
sure.
yeah.
Did you?
But
I don't know if you,
anywhere.
Paul, if you remember that funny story of the shop that shall remain nameless down in
Yes.
Florida that installed a overhaul prop governor and screwed up the installation. So and went out and ran up the engine, couldn't cycle the prop, and the IA in his infinite wisdom said, "Well, maybe it'll work in the air."
Let's try it. Let's fly it.
So he took off and he overspeeded the engine to the point where there were valve strike signatures on the pistons,
wow.
and
Yeah.
so the whole thing had to get torn down. And I think the shop was on the hook for
Yeah.
all of that.
I had a customer, the very same thing happened. He went to there's a Bonanza, went to a shop north of us and had a new engine installed. And on his return flight, and he did everything wrong. I told him, don't show up on a Friday afternoon to get the airplane, and certainly don't show up on a weekend. Well, he showed up on a Saturday, and the mechanic was out there, and they'd been doing ground runs. And he said, he asked the owner, where do you like your maximum RPM set? And so I'm hearing the story after the accident, right? And I'm like, why would a mechanic ever ask you what maximum RPM you want? I mean, there's one
There's a
maximum
book
RPM.
value.
It's labeled right there.
Yeah.
It's this nice little red line tells you what you want. Anyway, it was changing. And so again, someone said, well, let's fly it. I think it'll settle down. So they
Oh.
flew around the airport for like 10 or 15 minutes. There were two friends of mine in the airplane. And they said, oh, this is all good. We'll come home. And maybe halfway home, the RPM shot up. The last thing, the guy sitting in the right seat's looking at the tachometer. And he said the last number he was able to see
Before it starts
3,000.
shaking.
was 3,100 RPM.
Oh my
Okay.
God!
And the whole instrument panel was a blur. He said the engine sounded like a chainsaw. But suddenly, I mean, they had all this RPM, but they weren't going anywhere. And there's almost no thrust at that point because it went to the low pitch stops.
Yeah, yeah.
They landed two of the prop stud bolts.
Pulled out of the
They
hub.
were totally out there laying at the bottom
Yep,
of the cowling.
I've
There
seen
was
that.
Oil everywhere. Yeah, well, the race planes.
Yep.
Yeah, so it looked like some race plane had throttled up at the start and a little too fast, and everything came anyway.
Don't
Yeah,
mess
but
with
they did
it.
the same thing, Mike. They forced the prop governor on, and the beveled gears slipped past,
Mm.
Oh,
and so the prop
interesting.
governor wasn't. It was kind of rubbing on the gear.
This is
It
a
wasn't in
Continental
all
engine
the.
thing.
How could they even bolt it on if it wasn't fully engaged into
Well, it's a spline shaft. So when you
Oh.
put the top governor on,
It's remarkable how much force you can apply with a torque wrench.
oh gosh. So the prop number goes on within like a quarter of an inch of being in place if you don't have the splines lined up.
Okay.
And so you put all the nuts on, and someone
'em
says,
down.
well, we'll just use the nuts to pull it up into place.
Yeah.
And they just press that gear
Bad
right
idea.
past. Oh gosh.
Airplane mechanics are so industrious.
Man, I'm telling you, and it happens more frequently than you would like to
Yeah.
believe. Anyway, sorry, squirrel.
Yeah,
Philip.
that was a squirrel hole, but
Yeah.
interesting stories.
Yeah, we got millions of them, Philip. We got lots of stories.
Anyway,
That's great.
it sounds like what you did was good.
Yeah.
Yeah,
Yeah.
good
Now you
job.
understand why.
Thank you.
Yeah.
Yeah, that gives me a better understanding of how that all works.
What kind of hot rod airplane was this? Or
Yeah.
is this?
So
glass air.
it's actually a super cyclone. I don't know if you're familiar with those. I think there's
No.
one or two flying in the U.S. right now.
I don't know what that is.
Super cyclone.
Cyclone.
Super
Interesting.
Cyclone 185. Yeah, there's a company going to make them now out of Oregon, and I think they're going to be called 185EX or something. And it's an experimental 185 essentially.
Mm-hmm.
Oh,
Is it
like a Cessna 185. So
Yeah.
it looks
so it's a tail dragger for backcountry? Yeah.
Okay.
Yep.
Okay. Very cool.
And
Yeah.
why are they doing a
Very cool
520
airplane.
instead of a 550?
Probably
I don't
the
know.
shape of
That
the
was
cow.
what the original builder installed. So that's what
Okay.
came in the airplane.
Probably
Because they had a bunch of them in stock.
lying around. Yeah.
Exactly. Exactly right.
Yeah.
Right.
Well,
Awesome.
very cool. Great question, Philip.
Yeah.
Thank you.
Thanks for questioning why you did something some
Yeah.
way. A lot of people just say, okay, there goes another happy customer, but it's
Yeah.
good to know why.
Right.
Good job.
No, it caused some arguments in our shop as well. So
Ah.
we were trying to figure this out for a long time.
So, and the good news is
for
my
how-
husband was wrong, so I get to tell him that.
So for how many months is your shop schedule booked up?
We're out a month or two right now for sure. It's
Oh,
crazy.
everybody should bring their Continental
To Idaho, yeah.
inspections to Idaho.
Yeah.
Then
Yeah.
okay.
Oh boy. Yeah.
Should set up a production line to do those.
Do you know
those
how to
inspections.
replace a
go.
cantilever spar on
Yeah,
the
right.
210?
We're actually have a few of those lined up for the spar inspection.
Oh, really?
So we're gonna be.
Yeah.
We might be doing a few of those. Yes.
Hopefully you don't.
Yeah.
Hopefully we don't. Yes.
Yeah.
Check those headliner screws.
Yeah, I hope you
Check
like
that
taking
street.
interiors out of airplanes. Ugh.
If it's a
I don't,
P210,
no.
I can tell
No.
you don't want to replace that spar on a P210. That
Oh, I
is-
can just imagine.
Oh,
Yeah. Once you get all the
Yeah.
bolts out and all the rivets out, it still won't come off.
Because
Right.
it's sealed
It
in
was
with
it
like,
was super glued in place. huh?
PRC,
super
man,
glued.
I'm telling you, I don't know why they wasted all that money on rivets and bolts. They should have just glued it in there. It'd have been done.
I'm sure the PRC would have held it fine.
Oh yeah, you'll
yeah,
find
yeah,
out.
yeah, probably.
Yep.
Yeah.
All right, get back to work.
Yeah.
Alrighty, I'll do that. Thanks,
All right.
guys.
Philip. We'll see
See ya.
you.
Our next question is from Steve, who has found something about engine monitors he doesn't like, as if that's even possible.
Oh,
Go ahead, Steve.
Yeah, I guess my complaint or concerns or questions are about digital revolutions that are happening in our cockpits. We operate a PA 32300 with an IO 540 K1A5, and we have a CGR 30P engine monitor. And the Lycoming operator's manual lists numbers for the oil pressure as max 95, min 55, idling 25, startup and warm up at 115 psi. The POH has different numbers for some reason. It has 60 to 90 for a green range, green arc. A yellow of 25 to 60, that would be the lower range. The red line minimum of 25 and a red line maximum of 90. Here's the problem those cause is that our engine monitor came configured with master warning and master caution capability, red and yellow lights respectively. And our airplane, when it's cold, exceeds the 90 psi POH number by about 5 to 7 psi. So what happens is on takeoff, it jumps to 95 or 97 psi. and our master warning light, which is right above our our G5, our primary flight display, starts flashing. Now, most private pilots have no idea what a master warning or caution is for, but a blinking, flashing red light right in your face really should mean something, right? I think even the average knucklehead like myself would say, okay, reject the takeoff and figure out what's going on. But now with this new digital capability, there it is, it's just become a nuisance light, and we've just grown to ignore it. Now, if something else was going on and we just ignore it, that's a problem. So since my original question that I submitted to Ian was, why is the POH different from the Lycoming manual, and should we be able to change the settings in our engine monitor? Well, since submitting this, I have discovered that yes, you can change the engine monitor ranges for pressure, but it has to be done by the manufacturer of the engine monitor, and you have to submit a form which is signed by an A&P that says, yes, you can use these numbers, and there's a nominal fee.
It's called a CYA form because because they don't want the liability at the engine monitor place. They want to put it on your mechanic. So that makes total sense.
This is a pet peeve of mine that
I knew Mike would have something.
That some engine monitor manufacturers have made the alert limits non-user programmable, which is and they hardwire them to the manufacturer's red lines. The fact that you've got a yellow alert too is a plus. That's helpful, but it's still, you don't have control over where it goes off. So if you decide that you have a personal CHT maximum of 420 degrees, you can't just go in there and say, well, I'm going to set the CHT alarm at 420.
Right.
With some manufacturers, you can do that, like JPI, and some manufacturers have chosen not to do that. Now, there's some valid reason for that for engine monitors that are primary instrument replacements, where you're ripping a whole bunch of factory gauges out and putting the engine monitor in.
Yep.
But the CGR30P is typically not a primary replacement device. It's a supplemental device. I saw a whole bunch of steam gauges in your airplane that looked like they were
still
put there by the factory when Piper built the airplane. So in a situation like that, I just think there's no justification for the manufacturer not making those user programmable. Having said that, even if they have to be set by the engine monitor manufacturer, they should be willing to set it to what you tell them to set it. And apparently they are. You said that you can submit a form, send the instrument in, and they'll flash the firmware. It's a shame you can't do that in the field. It's a shame you have to send the engine monitor back to do that. But at least they're willing to do that.
Well, actually,
my sense is.
Oh, sorry. Actually, they send you a thumb drive and it reprograms it in your hangar.
But they charge you for that.
So you don't have to send it
But they charge you for the thumb drive.
Oh, that's not so bad.
Do you get to keep the thumb drive? I mean,
they probably
it only works once.
They probably don't charge you that much. Maybe you could reverse engineer it.
It's a very expensive thumb drive. That's all I'll say.
But just from my meager knowledge of Lycoming engines, the POH sounds like it's just completely wrong. I have no idea where Piper
why
got
would the
those
POH
numbers.
be more conservative, Mike, than the?
It's just wrong. It's just wrong to say that 90 psi is redline in a Lycoming.
Yeah.
You can't hardly
Lycoming, the Lycoming green arc goes up to 95.
Yeah. Well, you
the
can't
red line
hardly
should
idle
be,
this engine in the winter when you first started at below
Yeah.
90
It-
psi.
and
Yeah.
I mean, if you just couldn't solve this problem, then the solution would probably be to adjust the oil pressure down just enough so it doesn't quite trigger the red light.
Yeah.
But that shouldn't,
You shouldn't
that
have to
shouldn't
do
be. That's the tail wagging the dog. For an engine monitor manufacturer to
Right.
be telling you how you should adjust your oil pressure just seems so wrong.
Yeah.
On so many
Well,
levels.
And that led to the second part of my question is that, why are the POH numbers different than the LICOM numbers?
Yeah.
Can anyone explain who is making the choices regarding the presentation and intended use of this digital information? And is there any standard to which the manufacturers of these devices are being held?
Well, hang on.
'Cause,
So
I mean-
your digital information is aftermarket. So that has nothing to do
I-
with
with the original.
what
certification,
Piper did in their certification. It's really not that uncommon for the airframe manufacturer to put different numbers on engine parameters than the engine manufacturer does. Columbia did that. If you look at their their maximum fuel flows for a Columbia 400 in the limitations section of the manual, it'll say the maximum fuel flow, I'm rounding these off, are like 36 to 38 gallons an hour for takeoff. But then you flip the page and it talks about the markings for the gauges, and it'll say red line is at 40 gallons an hour. So even within the POH, it has two different numbers as maximum. And Continental says for that engine, 36 to 38 is your maximum fuel flow. What Columbia kind of sneakily, something like that. That's a new word. They snuck in that they needed a little bit more fuel flow for the climb to keep the CHTs down. So they added another couple of gallons an hour and put red line at 40. Works just fine. So I don't know why Piper did this, but it seems to me and I don't know, is this an instrument installed as primary?
Well, I would think yes.
I mean,
There's no
round gauges
manifold
been-
pressure. There's no manifold pressure gauge left. There's
okay.
none of
Yeah.
cylinder head, none of that.
Okay,
Tomato
so-
flames. None of that exists anymore except for the CGR 30P.
Okay,
What
so
were all those little
it's been-
square gauges that I saw in
Those
the
are
video?
fuel
Well,
gauges.
that is the fuel gauges.
Yeah.
Fuel
Yes.
quantity.
Yeah, they have
Yeah, fuel quantity.
tanks.
Okay.
So
We didn't get that option, but you could install 4 fuel sensors and then have
Okay.
it monitor.
Then
Gets
they
a
have
little
some.
crowded.
It is.
it's primary.
I actually think that's probably good. They probably are required because it's primary to have factory control over where those alerts are, and they do have the facility for you to update them in your hangar with the thumb drive they provide. And if they say send us a form signed by an A&P, we'll send you a thumb drive. That sounds pretty reasonable to me.
Yeah.
Well, it would be nice if you got maybe one mulligan, because when you fill out the original data sheet, you don't know that in the cockpit you're suddenly going to be faced with, do I reject a takeoff because the oil pressure is working fine, but it's going to go over the limit in the POH?
Well,
You don't know that up front unless
So-
you're really, really savvy, and I guess I'm not.
so think about before you got the digital engine monitor, you had analog gauges, and let's assume that they were correct and they were giving you the same information. The only difference is the old analog gauge still had a red line at 90 psi. The difference is it didn't give you a flashing light.
Yeah,
if
there's
you're on-
no
if you're
flashing
on
light.
But if you're on takeoff and you go past red line on oil pressure, your response would be the same with an analog gauge versus a digital gauge. There shouldn't be any difference in your mindset. You've exceeded red line oil pressure.
Well,
But
I'm
but
not so
Paul,
sure of that.
you agree that 90
No.
psi is not a reasonable red
too
line
low.
I
for a
totally
Lycoming
agree.
engine.
I absolutely agree.
See, I just
That's
think you
not
should tell
reasonable.
everybody, well, I don't know what engine was in this airplane when it was certified, but we have a highly modified one that has the IO 540 K1A.
What I was hearing though is that Steve is somehow attributing the problem to the fact that he now has digital engine displays.
Well,
And
but
the
got a
digital
flashing
engine
red
display-
light
flashing
in
red
his
light is
face.
much more distracting
Yeah.
than a little needle that goes over a red line that isn't even in your scan.
Right, but what I'm trying to my point is that the red line has not moved. It's in the same place it was,
Yeah.
and you are still getting over red line performance before you put in the engine monitor. It's just nobody
So
paid attention
Paul's
to it.
solution is to put
Well,
a piece of tape over your red
I
I
light.
think
That's
you
all.
should
He just wants
unscrew
to-
the red light and move
No.
on.
No, you should pay the guy the $50 for his little thumb drive.
It's
and
probably more than 50
Yeah.
bucks.
get this
but yeah.
corrected.
So you would get it up to, what are they going to let you get it up to? 95?
Well, I'm gonna set it based on the Lycoming numbers that it would be a caution light from 95 to 115.
Absolutely
I think that's
correct.
good.
Yeah.
Yeah, that's great.
And I think you should dump the contents of the thumb drive and see if it's something like a plain text CSV file that anybody could fiddle with
And
then
hack it. Yeah.
Yeah, exactly.
Spoken like a true
or send it
computer
to
guy.
me when you're done, and I'll hack it
There you
Oh
go.
my God.
or try to.
It's just the introduction of this digital stuff in our cockpits it can become, you can become obsessed with it, and it can be somewhat
Yes.
overwhelming.
It's like watching
Like
TV.
I know Mike,
Yeah.
I know Mike, you frequently have to answer or not answer questions about where do I set my exhaust gas temperature
Yeah.
when I'm lean
Not
at peak.
answer questions.
Yeah.
Well, that didn't exist before digital things gave it a number, which is
Right.
arbitrary.
You set it
Yeah.
by noise or the seat of your pants,
Yeah.
right?
Yeah.
Yeah.
No, it's
So,
true.
and Paul, in response to the analog gauge, when you glanced at your analog gauges on takeoff, if it was at the top of the green arc, the width of the needle was probably 5 psi. So
Oh, yeah.
you'd say, oh, it was fine. It wasn't zero. That
So
would
what
be a
you're
problem.
What you're really upset about is that the digital doesn't give you a fudge factor.
Yes. I want a bigger hysteresis gap.
Electronics International, who makes a very, very fine instruments and has very good customer support, but they're the original villains that started this whole thing. Because back in the day, we had these Alcor analog gauges, and Al Handari cleverly didn't put any numbers on the gauge.
Yeah.
Okay.
They are
a range.
awesome.
And then Insight came along with their gem, and they didn't have any numbers on them either. They just had a
Bar
LED bar graph, And then Electronics International came along with a digital display.
Evil.
And then so
No.
everybody now had to have a digital display because we couldn't let Electronics International, and they were claiming, accuracy to 1 degree, like we really need
boy.
that, right? and so then Insight came along with a gauge that showed both, and JPI came along with a gauge that both had a bar graph and digital display, and everybody is fixated on these numbers, with the purported accuracy down to 1 degree, and it just started the whole ball rolling in the wrong direction. Al Handari had it right. Don't put any numbers on the gauge.
Yeah.
That's
Well,
right.
the other thing that bothers me is when I'm watching, I try not to watch EGTs, but they jump all over the place, right? They're not like rock solid at one number. The numbers are going up and down and sideways, and it's very distracting. It would be
Yeah.
nice to just have that bar.
Yeah,
and an area which
I-
should be in.
on the JPI instruments, there's a programmable option that says round them off to the nearest 10 degrees so they don't jump around too much.
That's a good idea.
But most people probably don't enable that option.
Yeah, I
They
should
wanna
play with
see
it. Yeah.
They
No,
also
that-
blank out the last digit on tachometers as well. You notice you don't have
Yeah.
the
Right.
ones. It's
The
only
ones.
the tens.
That's
For
good.
that very reason. Yeah.
Yeah. Well,
No, we love the CGR 30P, and we love the amount of information you can get.
That's
It can just become a distraction, and normalized. That's the best mode because it's just they stay
Yeah.
the same. Nothing
Yep.
jumps around.
Yep, good point. Yeah.
So-
By the way, that's a beautiful looking panel. That's a nice
Yeah,
job.
it is nice and
Yeah.
clean.
I was looking for the light, and then I'm like, wow, look at that panel. That looks really clean.
it's been a work in progress.
Yeah, I know. I just went through that with my Cardinal, and now I love flying because I love staring at that panel. It's beautiful.
Yeah.
Those-
Don't forget to look
those-
I
outside.
look outside sometimes. Yes.
Was that
Well,
a pair
that's-
of Garmin G3Xs that I saw on there?
Two G5s.
G5s.
G5s, okay.
Yeah, yeah.
Yeah, a pair of G5s, and
Very nice.
a plan to put a
Very-
third one in on the right-hand side.
Wow.
Oh, interesting.
Very nice.
Very cool. That's a nice setup. I
Oh,
love the new
and-
technologies.
Yeah, but we have other digital issues. I don't know if I have time, but you update the software in your GTX 345, and suddenly your flight stream quits distributing ADS-B because its software is out of date.
Oh yeah. Yeah.
And
well
there's
aware of
there's no AD system for this. You just find out by doing. You're flying along and you look at your tablet and I'm not getting traffic anymore. Oh, something's wrong.
that. Yeah.
You have to be a computer wizard to run your avionics these days.
It's sucking the brains out of our head.
Well, Steve, great question. Obviously generated a lot of discussion, and we appreciate you coming on the show.
Yeah.
And sitting in your car and talking
And
to
sitting
us.
in your car. Next time, call from the airplane.
Yeah.
I'm sitting outside the hangar. It's 10 feet away, but
Probably too cold.
thank you so much for everything you guys do. And this is like my brush with greatness moment. You
Oh,
run into General Yeager in an elevator. I got to talk with Mike Bush. This is fantastic. And Colleen and Paul, this is wonderful. Thank you.
We're all here. Okay. Well, great. Thanks for calling in.
Have a great
care.
day.
Thanks.
Bye.
Our next question is from Dubs, who has a thought experiment about manifold pressure. We love thought experiments. Go ahead, Dubs.
Well, thank you. I've been flying. I retired 5 years ago, bought a Mooney, 42-year rusty pilot, started flying, and now have 420 hours in it. And I still don't understand how my manifold pressure is working when I am going up to altitude and starting to set up for cruise. So the manifold pressure can be reduced two ways. You pull the throttle, which interferes with the flow in the carburetor, and less air is getting through, or you go to altitude where the air is thinner. So my question is, when I take off, and I'm from the Sacramento Valley area, so when I take off, basically sea level, when I take off and start climbing, at 1,000 feet, I check my EGT and fuel flow, and the EGT is about 1395, fuel flow 17.2. And as I climb, then I'm actually leaning the engine as I climb to keep that EGT at about 1395. So at 2,000 feet, the fuel flow is down to 16.7. So I'm reducing the fuel flow as I climb, which I should. But when I level off at 6,500 feet and let the plane settle down, drop the prop back to 2,400 RPM, and then what I'll do is pull the mixture back so I can lean. I pull it back till the engine stumbles, and then just push it in till the engine doesn't stumble. Now I let the engine settle down, and what happens is at that point, I end up with a fuel flow of about 9.5, but my manifold pressure is down to 23 because I'm at altitude. So now I pull the throttle back, and as I pull the throttle back, nothing happens. I pull it back, not the throttle, I'm sorry, the manifold pressure. I pull the manifold pressure back, I pull it back, and the manifold pressure needle doesn't start twitching until I pull it out a ways. And then I let it set. I set the actual lever at the same point at the 23 that I have naturally received by altitude. So the question is, I got two questions, because what happens when I do that is my fuel flow goes down. My temperatures come down, EGT, CHD, and my fuel flow comes down when I pull that back, but the manifold pressure doesn't change. I pull the lever back to 23 inches. So I don't understand if I'm pulling that back and I'm reducing the airflow through the carburetor, as well as the airflow is being reduced because it's thinner, why hasn't the manifold pressure going down as soon as I pull the lever? And if it doesn't go down, why do my numbers drop? Fuel flow, temperatures, why are they dropping if the manifold pressure doesn't drop?
I missed something here. What kind of engine is this?
Yeah.
It's an O360, carbureted O360.
So it's an M20C?
I actually have a G, which is the same as the
G.
C. It's just
Right.
longer.
Yeah, the long cabin, but the small engine.
Yeah.
Do you have the Ram? My dad was a
Ram Air.
Mooney fan, a big major Mooney fan. Does it have the Ram air valve on the front? So
No.
once you get over, it doesn't have that. Okay.
No.
Do you still get ram air effect at cruise? You get some.
You do
improvement.
get some.
Yeah.
But what you're talking about is something that bypasses the air filter, and
It bypassed the
Yeah.
air filter, but
Yeah.
it didn't put heat
Which-
in.
my Lance Air has
Gives
that,
you
yeah.
about an extra
at
inch or
least.
so. Yeah, it's just
it's
pretty
great.
helpful. So I'm just trying to get some understanding. When you get to altitude, you're saying you're pulling the throttle back to 23 inches of manifold pressure, but it's not changing. So
Well, it's
So it
already
does
at
change,
23. It's already
just
at
pulling it
23
back.
automatically, naturally. But as I
Yeah.
pull the throttle back, it doesn't change until some point. Then it does change, and then I'll push it back into where it's at the 23, to where the
Why do
throttle
you-
matches what it wants to be at anyway.
and why do you do that?
Yeah, why do you move the throttle?
Why
at
are you
cruise?
pulling the
Why do I
throttle
do that?
Yeah.
Why not
Yeah.
wide open throttle?
I did it once and my fuel flow went down. So I said, hey, I want to use less fuel.
Don't you want to get there?
Yeah. So the way,
Well, no.
Michael have
My
even-
speed didn't change. I did a true airspeed calculation before doing that. It was 162 miles an hour, true airspeed. I pull that back until it matches the actual 23 that I've got already. My airspeed is still 162.
Sure. But what you've done is you've changed the position of the butterfly valve in the carburetor.
Correct? Yeah.
But that won't change manifold pressure very much until suddenly it does. I mean, it'll change the flow, but it's not being very restrictive. But it also does change the fuel flow as soon as you start pulling it back. I always leave my throttle full wide open
Yep.
and reduce the fuel flow with the mixture knob
Yep,
and
yep.
not with the throttle knob.
Okay, but Paul, you're relating this to an injected engine, and he has a carbureted engine,
Yeah, so he may have the
and there is
accelerator.
no linkage between the throttle position and
Fuel flow?
direct linkage
Well,
throttle position fuel flow.
other than the airflow, which is sucking the fuel in
Yeah,
with
the
cherry.
carburetor compensates for the
So
airflow.
it's changing the airflow, but maybe not. It's changing the velocity of the airflow.
Well, now that it occurs to me, he may have a carburetor that has an enrichment circuit in it,
Right,
that-
like the
that does-
182s.
Yeah, that does provide extra fuel flow at wide open throttle.
So
Some
that's what's-
carburetors have an enrichment circuit that does
So when
that.
you move the throttle initially, it's changing the mixture before it ends up changing the manifold pressure?
But even still,
Yeah, I
why
bet that's
wouldn't-
what's going on.
why wouldn't you just leave it full forward and adjust the mixture with the mixture control?
Well, I do that and I pull the mixture control till the engine stumbles. And then I have to enrich the mixture to where the engine is smooth. And then at
Sure.
that point, I'll pull the throttle until it actually twitches the manifold pressure needle. And then that reduced my fuel flow from 9.5 to 9.3.
I see. So you get an added fuel flow reduction, but the engine doesn't stumble.
Correct.
Because you've changed the airflow
Yeah,
this time.
actually,
at the same time.
what Dub is doing is excellent practice if you're flying a Cessna 182, which has miserable mixture distribution. And one of the things we found with those 0470s that have really bad mixture distribution, where the rear cylinders run lean and the front cylinders run rich, is that by pulling the throttle back just slightly to cock the throttle butterfly just a little bit, it introduces turbulence into the airflow through the carburetor and improves fuel atomization, and it makes the mixture distribution better. It's still not great, but it makes it better. Now, I wouldn't really expect there to be much of that effect in a Lycoming, because the Lycomings have a pretty symmetrical induction system.
Yeah, and he's not doing it for that reason. He's doing it because he wants fuel savings.
But, if you think about what happens when you start tilting that throttle butterfly, it's very, very nonlinear. The first 5 or 10 degrees of tilt doesn't really have that much effect. And as it tilts further and further, it has an accelerated effect. It would be linear if it was like a slide valve or something rather than a butterfly. But butterflies are very nonlinear in their effect on the airflow.
It's like sticking your canoe paddle in the water and then feathering it. You can see it. Initially, the water will stick to the paddle, just like airflow over a wing.
Exactly.
But then at some angle of attack, it starts to.
Yeah, you get critical angle of attack. I've never thought of it that way, but that's a good point.
So I wonder if you, since we're thought experimenting here, if you began by pulling the throttle back, and before you do the mixture pull the throttle back until you get that fuel flow change, then just that little bit of manifold pressure change, and push it back up, and then pull the mixture back to roughness and leaning. If you end up at the same spot, I would assume you would.
I've actually tried to do an additional leaning after I pull the throttle. I said, well, let me see if I can lean it again and get any difference. So I'll do that again. And as soon as I pull it out a little bit, the engine goes a little rough. I put it back in, check the numbers. So I'll continuously do that. Actually, every 10 or 15 minutes, I'll play with that, as I'm flying along. If I'm on a 3-hour flight, I do that multiple times, and just to check it.
It doesn't change anything, I'm sure, but what else you going to do? Do an in-flight mag check just to break it up. Don't do
you
the
need
same
an
thing
engine
over
monitor
and
so
over.
you can watch TV. That's what.
There you go.
Yeah, but if you actually can reduce the fuel flow a little bit more before the onset of roughness with the throttle pulled back a little bit.
That's what I was thinking. If he
then
did
that's
that
telling me he is improving his mixture distribution, because that's what's causing the roughness. Is mixture maldistribution.
Yeah, one cylinder quits firing before the others.
Right.
I would give it a shot at pulling the throttle first
power,
and then do the mixture pull.
That would make a lot more sense to me, Paul.
Yeah, give it a shot.
Interesting.
Okay,
like
so
you said, what else you going to do? You're flying for 3 hours.
Yeah. Okay. So what you're saying is to pull that throttle before I do the leaning. Leave the full rich, and once I level off.
But you're not full rich.
Well, I'm not full rich at that. I'm sorry.
Right.
No, I'm not full rich at that.
Whatever lean you are, leave it there.
Yes.
And do the throttle
Just the
first.
throttle first.
Right. Do the throttle first, and then do that.
Then do the lean. See if you end up at the same place.
Well, it's interesting because I've actually, when I did this the other day to get these numbers, and I was surprised when I came out at 9.3 gallons an hour, because when I'm flying any kind of distance, I end up getting down to like 8.7 normally. So I got that 9.3, and that's where it was. And I said, well, I got to document it that way. So maybe you're right. Maybe if I do it the other way, I'll even get better fuel flow.
So
this is another one of those digital instrument things where if all of this stuff is like less than a needle width, nobody would even be noticing this.
Wouldn't even be bothering it.
We need another digit.
One more digit. So Dubs, what engine monitor do you have?
I have a JPI 700 engine monitor and a Fuel Scan 450.
Okay.
Yep.
So have you done a gaming lean test on this engine?
No, because I don't have injectors.
You don't care.
See,
You can still do the
I-
lean
still
test.
We
do the
get
lean
so
test.
much of that.
Yeah.
Oh, I
Yeah.
see.
You do
Yeah.
a gammy lean
Uh,
test on any
any
engine as long
engine.
as it has more than one cylinder.
But
You
it
can't
has
do
the
it
word
on one
gammy, so it implies you
Yeah.
have gammy injectors.
I always thought it was an injector
No.
No,
balancing
it
issue.
has nothing to do with gammy injectors. It has
It's
to
a
do
fuel flow
with
test.
George.
Yeah.
Yeah, George from Gammy.
So do
Oh.
this because you're on this 3-hour flight. You got nothing better to do. So
Yeah.
let's occupy your time. Do the leaning without pulling the throttle back. In other words, leave it at wide open throttle, lean the
Okay.
mixture, do a gammy lean test in this process. Go from rich to lean, lean back to rich. So you get 2 scans. You can do it both directions. After you get back to the rich side, excuse me, then pull the throttle back as you do to the 23 inches or whatever,
Yeah.
and do
And do
another
another one.
gaming test and see what kind of results you get. You're
What
going to
you're
find
looking-
out if you've
And
got better
maybe
fuel
the
distribution.
spread will be a little bit less. It
It'd be
definitely
great
is.
if
in
all
over 70s, that's for sure.
Yeah.
you want all the
I-
cylinders to peak at the same fuel flow.
And then let us know.
Yeah.
Yeah.
I don't understand what you mean by go rich to lean to, so, because I don't know actually if I'm lean of peak or rich of peak, the way I lean the engine. I've tried
Right.
using the JPI 700, lean fine and do all that.
No,
and I don't
forget
get
all
good
that.
results. No, that sucks.
In
Yeah,
your
that doesn't work.
climb,
But
Okay.
this is for the test. This is not the way you
Right.
normally are going to fly the airplane. The way you're doing it, the way you're leaning is absolutely
Perfect.
good.
Yeah.
Okay. The lean test is something we do to gather information about how good or bad the mixture distribution between the various cylinders is. And basically it consists of, and we want to do this at relatively low power. So if you're up at 6,500 feet, that's fine because
Perfect.
you are at relatively low power. And very, 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 very slowly pull the mixture control out and note the fuel flow at which each respective cylinder reaches peak EGT. And it's good to do this a few times to get accurate numbers. And what we're interested in is what's called a gammy spread, which is the difference in fuel flow between where the first cylinder reaches peak and where the last cylinder reaches peak. The first cylinder will be the leanest running cylinder. The last cylinder will be the richest running cylinder. If the engine had perfect mixture distribution, which it doesn't, they would all peak at exactly the same time. But
Which temperature am I watching? Exhaust or cylinder head?
exhaust gas temperature.
Okay.
EGTs.
All right.
And you're doing what you normally don't ever do, which is you're leaning very, very slowly so that you can accurately determine where the peaks occur. And you're interested in the fuel flow difference between the first cylinder to peak and the last cylinder to peak. And what Paul is, and that's called a gammy. It's measured in gallons an hour, and it's a measure of mixture distribution. The smaller the number, the better the mixture distribution. In a perfect world, the number be
They'd be
zero because they'd
zero,
all peak
yeah.
at exactly the same time. But that's not what really happens. So Paul is suggesting doing that test twice, one with the throttle all the way in and one with the throttle retarded just a little bit, and seeing whether retarding
It's
the
different,
throttle
yeah.
improves the gammy spread, makes it smaller. Our theorem is that it probably is doing that, but it would be really interesting to verify that with the test.
And
And
you
you-
don't have to write those fuel flows down. You can pull the data off your.
Well, I
No,
don't know. He
because
doesn't have the fuel flow.
he doesn't have the fuel flow option on his EDM
I don't have
700.
fuel flow. Right.
So you have to
And
get
when
he's got-
I pull my data, when I pull
Okay.
my data, all I got are the 2 temperatures.
So
So
bring a
you're
pen
You're
and paper.
going to have to write them down. So
Yeah.
it's best to
Yeah,
have a
right.
Confederate along with you to do that, so that you can fly the airplane.
Confederate. So if you go
So
to the GAMI
is-
site, it describes this process in detail, and they have a chart that you can print and write all your data in, which makes it,
Okay.
it makes it kind of nice.
Is there a
But-
guideline as to how those, if they're 50 degrees different or 200 degrees different, is there a
It's not
guideline?
about
as to what's
temperature.
The
It's
spread
not
is measured
temperature.
in gallons an hour. It's not
Yeah.
measured in temperature.
You don't care at
Okay,
what temperature
okay.
the EGTs peak. You care at what fuel flow they peak. That's
Yeah.
Okay.
so, but also in your climb, you're rich of peak. When you take off at full rich, you're at 1395, I think you said on your EGTs or as an average. And when you climb, you're leaning to maintain that EGT. So which means you're still full, you're still rich.
Yeah.
You're maintaining that same fuel air ratio that you had at takeoff. So when you level off at your 6,000 or 7,000 feet to do this test, by definition, you are rich of peak.
Mm-hmm.
So you can start from that point and begin leaning, get all the way lean until it runs a little bit rough and all the EGTs have peaked, and you'll read the process on the GAMI site. Let it sit there for a minute. Go back to the same rich position you were before. That's 2 sweeps. Then pull your throttle back like you've been doing, until the manifold pressure just begins to move a little bit. And then do the lean test again and compare the results to that. And we would be very interested to see what
And
you
one
get.
more comment, because this is a carbureted engine. You may have to do this test properly. You may have to lean further than the onset of roughness. You may have to
that's
lean
true.
to teeth chattering roughness in order to get the richest cylinder to get to peak. The worse the spread is, the more that effect's going to happen. But so for the purposes of the test, don't be concerned about leaning to quite profound roughness. You need to get that last cylinder to peak EGT so you can see what the fuel flow is and get an accurate GAMI spread.
And I need to do this 4 times, once watching each of the 4 cylinders. So I watch cylinder number 1 EGT temperature as I lean.
We normally don't do it that way. You normally do it in a single mixture sweep. We like to do several of them just to make sure we have good numbers. But you're slowly leaning, and then you say, okay, first cylinder peak, what's the fuel flow? Write it down, and keep leaning till the second cylinder peaks, and write down the fuel flow, and so on.
You'll lean it like at 0.2 gallons an hour per change.
Very slow.
Yeah, so you got to pull it back 0.2 gallons an hour, write down all 4 EGTs. After they settle, pull it back another 0.2 gallons an hour, write down all 4 EGTs until you see all of the EGTs have peaked and started going back down.
Yeah, my display only shows one of the EGTs at a time. I have to.
That's okay.
I have to cycle through them to get the numbers.
That's okay. That's all. So you'll pull the fuel flow back, record, wait, let it settle. So you may have to give it 10 or 15 seconds for the EGT numbers to settle. Record number 1, cycle through, record all 4 of them.
Okay. All right.
And then pull the mixture back another 0.2 and do the same thing. It'll take a while, but again, you're on a 3-hour long flight. What else you gonna do?
And you're learning about your engine.
And you're gonna learn cool stuff about the engine. This is a blast.
Yeah.
So for injected engines, where we can tweak the nozzles and stuff, we want to get the GAMI spread down to something less than 1 gallon an hour, and ideally down to a half gallon an hour or so. With a carbureted engine, you're probably not going to do that well. On really bad engines like the 0470, it's not unusual to see a GAMI spread of like 3 gallons an hour. You'll probably do a lot better than that with your Lycoming. But what we want to find out is what that number is, and whether that number is better when you pull the throttle back just a little bit than it was when the throttle was all the way forward.
Yeah, you're not going to be able to correct it like by putting GAMI injectors in, but you're going to know.
At least you'll know where the best place to operate.
Yeah.
Okay. So you got a homework assignment. There's going to be a quiz.
Yeah. There's a reporting element to this homework assignment.
You have to report back to get full credit.
That's right.
Good. Well, thank you. I will do all that. In fact, maybe I'll go do that now. It's a beautiful day today. I may go fly.
You should.
Jump on it.
Absolutely. Yeah.
Fly
I
for
think
us.
I think all this time is loggable against his
Ah.
A&P requirements.
That's great.
Absolutely.
This is ground school.
There
Yes.
you go. All right.
Well, great
Dubs, we
questions.
appreciate the
Thanks,
call.
Thank
Deb.
you.
This is fun.
This is
Never
a lot
stop
of fun,
learning,
yeah.
Dubs.
Absolutely.
Yeah. Yeah, thank you.
Well, that's a wrap on another podcast. Did we get anything right? And what did we get wrong? We would love to hear from you. Just keep sending us those tricky questions and try to stump us. You can send your questions and comments to podcasts@aopa.org.
We'll see ya.
Bye-bye, everybody.